Hello everyone. Welcome back to Dr. Lou's VCE Physics channel. Today, let's learn together about the NHT 2023 physics examination. We will focus on questions related to Newtonian mechanics. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. A spring compressed between two trolleys. The spring is released, and the trolleys move off in opposite directions. The spring falls straight down. This system is isolated, so the total momentum is conservative. The total momentum is zero because both trolleys are rest before spring is released. Since trolleys move in opposite directions, their momentum. We know the mass of trolleys A and B and the speed of trolley A, so solve the trolley's speed from the equation, and the correct answer is A. Label the value of all variables in the picture first, which helps our thinking. All units should be converted to the International System of Units. After spring is released, the spring potential energy is converted into the kinetic energy. We solve the spring potential energy equation and get the spring constant. The correct answer is C. A mass is hung on a spring. Point Q is the balance point, where the gravitational force is equal to the elastic force of a spring. We substitute the force with gravitational force and solve this equation to get the spring constant. We further stretch the spring to position R. On position R, the elastic force is larger than the gravitational force, so the spring oscillates between position R and P. This position R is defined as the zero gravitation potential energy. On the position Q, the elastic potential energy is zero because the spring is not stretched. The position R is defined as zero level. Using the formula for gravitational potential energy, Arya calculates e.g. the position P is zero elastic potential energy. Using the formula for elastic potential energy, Arya calculates the S. Using the formulas for EG and S, verify that Arya's S equals 10J at position Q is correct and fill in the missing data points in the table. Step by step, calculate all values and fill them in the table one by one. 1 mark is awarded for one value. On the axes below, plot the EG and S versus position data for the oscillating mass. 4 marks are awarded for this question. 1 mark is awarded for an appropriate scale and numbers for the y-axis. 1 mark is awarded for an appropriate label for EG and S. 1 mark is awarded for the best fit through the plotted points for EG or S data. Before drawing the curve, please refer to the formula of EG and S. The formula of EG is a linear equation, so the curve fitting EG versus position is a straight line. The formula of S is a parabola equation, so the curve fitting S versus position is parabola. This system is composed of a mass and a spring. The mass of spring and resistant forces on mass are neglected here. So, the total energy is composed of kinetic energy, elastic potential energy, and gravitational potential energy, and remains constant in all processes. On position P, this mass is rest, and spring is free, so K and S are zero, and total energy is equal to the value of EG on position Q. The total energy is the sum of 3 types of energy, and we know the value of EG and S. The value of K is calculated with total energy minus EG and S. Finally, we solve the speed of mass from the K equation, which is valid for 2 significant numbers. Yes, the total energy remains constant, and it is the sum of 3 types of energy: kinetic energy, elastic potential energy, and gravitational potential energy. However, this graph only includes elastic energy and gravitational energy but does not include kinetic energy. If the kinetic energy is included, we will find that 3 types of energy have added up to a constant value. 2 multiple-choice questions are awarded 2 marks, and 1 short answer question is awarded 13 marks in Newtonian mechanics. The overall score for this section is 15 points. With a total possible score of 130 points, the percentage for this section is 11.5% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.